All right, clip number 3 of Chapter 11, Section 4 notes. In this clip, we're going to tackle the other namesake here to Section 4, being the volume of a cylinder. And there's an important reason why cylinders are grouped with prisms beyond the fact that they look kind of similar to each other, other than the fact that there's a different shape of the base. And that's really ultimately why, because we end up with essentially the same volumetric formula. Volume is equal to the area of the base times the height still. They even look similar other than the fact that the shape of the base is now a circle. So instead of having rectangle sides, I get just basically this one little wraparound circular side. If I were to actually unravel the side of a cylinder, it would turn into a rectangle. But in this case, the small difference here is that now that instead of me worrying about several different kinds of formulas for the shape of the base, and worst case scenario, having to end up with like a crazy base, like an octagon that I have to find apothem and side length in order to find that area. In this case, my base for a cylinder will always be a circle. And it follows the same rules as regular prisms. Both circular bases will be congruent to each other, top and bottom, however you think about it. And they're going to be separated by some distance. That distance is going to be the h value in that volume formula. And you'll notice I drew this again, that it's possible entirely to have a tilted version like Tower of Pisa, where it's slanted like that. And again, much like before, I'm going to imagine one of those bases resting on a table, and I'm literally just measuring the vertical height up until that next base. So in this case, you're going to see that we're going to deal with it in just a second. Again, I'm not going to care about the length of this slant to that slanted cylinder. Instead, I'm going to think about the perpendicular vertical height compared to that horizontal base. Okay, but essentially it's the same kind of formula. Find the area of the base. These bases just happen to be circles, so that'll be a reference to section 2, and most of us knew it before this class, but the area of a circle is pi times r squared. And then finding how far apart those circular bases are, that gives me my h value, my height or depth of this cylinder. So one thing to be aware of, particularly for these cylinder problems, is that we will not always be just explicitly given r, radius. I want to remind you that there are a couple different ways that they could express information that I'd have to extract that radius information from. For instance, in both these examples, I'm explicitly told what radius is. This one's 9 feet, this one's 4 centimeters. But what they could have done in these cases, for instance, in part A, they could have told me the distance all the way across the circle, also known as diameter. And if I knew the diameter of the circle, I'd simply cut it in half to find my radius. They could have told me the circumference of the circle, in which case I'd have to know that circumference is 2 times pi times radius. So if I know the circumference length, whatever that may be, I would divide it by 2 pi to find out what my radius would be. But that's important information to know because, again, it could be expressed in those different ways. And in order to use this formula, I will need a radius length. All right, let's jump to the whiteboard, solve these two quickly, and I'll talk about the variations we'll see. All right, part A. Part A is actually pretty close to like a real-world example of like a backyard pool, right? We get a circular base. Looked at from the side. I know this looks like an oval as it is, but we're looking at kind of like at an angle. That is separated down to some other circular base, congruent circular base, as shown like this. And the reason why I say it's kind of the equivalent of a pool is based on the measurements. The radius they tell me that I have right here is 9 feet. Again, they could have told me it had a diameter of 18 feet. Either way, I'd have the same radius value. And then the depth between these two circular bases, I was told, was 6 feet. Okay, so it's actually pretty close to like a backyard pool. And if I need to find the volume of this, the real world reason why I might need the volume is maybe I need to know how much water is going to be in this. Or if I was filling it with, I don't know, like a ball pit or something like that. All right, well, just like with prisms, my formula is the same. The volume of this shape is going to be the area of the base times the height or depth of this. What I'm going to see unique to cylinders is that the area of the base is shown by the area of a circle, pi times r squared. And then again, the h value is going to represent the distance between those two congruent bases. So because we're dealing with pi again, and I'll make sure I represent it here in these solutions, there will be a difference between exact answers and approximated answers. Just make sure you're paying attention to what the question's asking for. Most of the time, it's going to ask you to round to the nearest hundredth with just 2 decimal places, in which case I'm going to be imagining using 3.14. But for exact solutions, I would be leaving pi in there. So anyway, in this case, I'm just plugging in the information I know. The 9 feet is the radius to one of those circular bases, so 9 is going to go in for R. The distance between those two bases is 6 feet, so that's going to be this h value for 6. So I'll plug that stuff in, and I get the following. Right, pi times 9 squared, or 9 times 9, and then the h, or depth, between these two bases is 6. Well, just doing this math really quickly, I would deal with the exponent first. 9 times 9, or 9 squared, would be 81. So the area of one of these bases is 81 pi, to use exact phraseology. And then multiply that by a depth of 6 feet. So for the record, if I wanted to put this in exact volumetric numbers, I would just multiply 81 times 6. And that's going to give me a volume of 486 pi. That's an exact number, again, a non-approximated number. The units here are feet, or more specifically, cubic feet. So this volume right here, this is the exact volume of this swimming pool, for lack of a better term. But if I needed to round this to the nearest hundredth, I'm just going to do that 486 times 3.14. And so volume here is approximately 1,526.04 cubic feet. There it is in approximated form. Again, another way you might be presented this problem, bless you, maybe you knew the volume in terms of the exact number. Maybe you were told this pool has a volume of 486 pi cubic feet, and maybe you had to solve for the radius of the circular base, in which case I'd have 486 pi in for v. I would divide pi to the other side to get rid of those pi's. They'd end up canceling. I'd get 486 divided by 6. It would give me 81. And in order to solve for radius, I would have to take the square root of that 81, and I would find out that radius was 9. Okay, so in those cases where I'm given volume, I'm going to end up doing some inverse operations, but that's just the other way you'll see it. All right, let's move on to part B. All right, part B is where we're going to see one of these tilted shapes. So in this case, again, we're given a circular base, and then we get this slant to it. And then we get the following information. We're told the radius of one of the bases, distance from the center to the outside. We're told that this is 4 centimeters. So we're told radius explicitly here. Again, they could have told me diameter, in which case I just divide that by 2. They could have given me circumference, in which case I divide by 2 pi. In either case, I have the radius. And then they give me this information. Because it's tilted, you'll typically see this in your assignment, where they show me this little right triangle right here. What they're actually measuring is the actual vertical height of this tilted cylinder. And conveniently enough, they tell me that this is 7 centimeters tall, which is the exact piece of information I need for h. How far vertically are these two bases from each other? 7 centimeters, that represents h here. So before I move on, I want to quickly point out the different variations I can see on this. And this is another problem I'll end up doing after the recordings. But different ways they could present information here that have to do with the fact that I'm dealing with a right triangle. As soon as I have that little right triangle there, so when I see this with my tilted examples, my slanted examples, Pythagorean theorem could be used. So for instance, maybe I knew the slant length, which would be the same on this side as it would be on this side, and maybe I knew this distance for whatever reason, in which case I could use Pythagorean theorem to figure out this missing height. Another way it could be presented would be using trigonometry, which can be used for right triangles. Maybe I knew this angle, which is a far more realistic type of measurement to know in this case. And maybe I knew the slant length here, in which case I would use trigonometry to, again, find this piece. Whichever way you slice it, this is the piece of information I'm going to care about knowing. Whether it was tilted the opposite way, whether this was sideways, however you think about it, the piece of information I'm going to want to know is how far apart are these two circular bases from each other. And that's this measurement right here. So when I plug this into the formula, I get the following. The area of the base, again, here for a cylinder is going to be pi times r squared. And then the h value here is how far apart are the two circular bases. Thankfully, in this case, in this example, I have both these values individually. I can just plug it directly in. And so I get pi times that radius of 4 centimeters squared. And then the height, or how far apart these two circular bases are, in this case is 7 centimeters. So it's all done just straight computation on the right. Well, volume here is going to end up being, let's go ahead and do this exponent first. 4 times 4, or 4 squared, is going to be 16. So 16 pi is actually the area of each of the circular bases. They are vertically 7 units apart. So if I was solving this exactly, I would keep pi as pi. So 16 times 7 comes out to be 112 pi. Units here are centimeters. So this is my exact volume of this tilted cylinder. And again, if I needed to round it to the nearest hundredth, I would do 112 times 3.14. So to 2 decimal places, this is approximately 351.68 cubic centimeters. Again, another way it might have been presented, maybe I knew volume and I was solving for, say, the depth or that vertical distance between the two circular bases, in which case I would do this math and divide it into that number. The pi's would end up canceling, and then I'd end up with whatever value was left over. But that concludes our Chapter 11, Section 4 notes on volumes of prisms and cylinders. I'll go ahead and stop the recording right there.